Hello everyone and welcome to Houdini 20 Sexy Clouds presentation. My name is Attila Torok and I will be talking about, creating sexy clouds. So in this release, we concentrated on creating tools for modeling clouds, so as opposed to tools for simulating them. So when it comes to model clouds, the best example to look at is probably the Disney cloud. So if I could put a headline to this presentation, it would be something like, have you ever wondered how the Disney cloud was made? And maybe then this presentation is for you. So, and to figure this out and get some ideas how it maybe was done, I will be talking about the new cloud noise swap, which is the noise that effectively drives all the nice sexy details. Then the billowy and wispy noises, which are the new volume displacement tools. Then I will be talking about and showing you cloud generation setup from start to the beginning, and then how we can render these clouds out and to make them looking like what you see in the background. And then lastly, I will show you the new Skybox, which is an update to the existing Sky node, which lets you create procedural skyscapes. So that said, I will just jump to Houdini. And as I said, the Disney cloud is probably the best example to look at. So when I started the project, I downloaded it and gave it a good hard stare. And the observations I made are pretty obvious, but I will just go through them. So there are two distinctive noise types I can see here. One is largely on the top is the billowy details, and then some areas turn into these wispy details, so mainly at the bottom and here in the back. So then this is clear to me that we need to create tools that would allow you to edit and to displace volumes based on these two noise types. And also noticing that, for example, the billowy noise has these flat areas here, which just adds even more details to the cloud pattern actually. So we need a way to mask certain areas. There is also some way that we should clip cloud volume to make the cloud bottom flat. So considering all of this, probably a good workflow would be to provide some sort of basic shapes using geometries, then displacing them with billowy details, then optionally clip the bottom of them and select some certain areas where we can apply a wispy detail. So this is the workflow that I've been trying to implement then. So to start with, where do we start it? Well, the billowy noise probably would be a good start, how we can create these nice billowy details which you see in the clouds. So to do that, let's look at some real references. So this is like a large cloud image of a large cloud, and you can see all the nice billowy details all around the cloud. So what is my main issue with many of the, while you see lots of details here, my issue is that the way the cloud look, it's sometimes hard to see behind, the overly bright areas, and therefore you don't really see the details behind them. And therefore I started to look at other references where this kind of billowy nature is much more visible, and therefore I show you a picture of like a volcano pyroclastic flow from a volcano. So this, to me, I just made an assumption that in nature this is probably something very similar how the cloud patterns look like. And so what I kind of interested here is the what I call the sausage patterns, and I will be calling them as sausage patterns for the remaining of the presentation, or brain patterns. So you will see that you got these larger details, like for example this one here, which then made up of smaller details, and then those again kind of curling up as sausages, again divided into smaller details. So if I could describe it, it's like a sausage fractal, effectively layering smaller and smaller, like kind of curling, swirling sausage details. So how do we create this? So in Houdini, we now have a new noise type, which is called cloud noise. So if I just showing you here applied on a simple grid, this is how it looks like. So if I just go back, comparing it to all of these details here, it's pretty much representative. So, and how did we do it? So this cloud noise exists as a cloud noise. So this is labeled as cloud noise, but actually whoever knows more about noises and wanna be more precise, this is actually a cloud fractal. And the difference is that the cloud fractal is actually layering cloud noises on top of each other with different varying element size and amplitude. And to show you this, if I set the distortion to 0 for the cloud noise, you will see that I'm getting exactly the same simplex noise as I would be getting with an attribute noise as well. So this is just a simple custom fractal. And as you see, distortion is the key factor here. So as I move the distortion up higher on the positive direction, you will see the sausage effect is getting more prominent. So what I'm doing is in each fractal iteration, I'm just pushing areas with higher values towards the areas with lower values. And if I go to the negative side, you will see the opposite happens, and I'm getting these very stringy kind of fiery looks as well. And the parameter is sort of optimized that between -1 and 1, it gives the best result. So, and then there are a couple of other interesting parameters to mention. For example, the fold. Then you will get a more prominent kind of sausage look. Again, we can compare it more to these kind of details. Then what is interesting is the droop, which if I now starting to move it, the details will be stretched, moved along the droop direction, creating this kind of interesting like wet paint effects, let's just say. And then there is one other parameter to mention, the add whirly details, and I just enable gamma here to see it better. So this is coming from the guys who did Horizon Zero Dawn. So they did some amazing work on cloud generation for games, and they've been already doing many presentations about it. And one of the things they're mentioning in their presentation is this thing called the Perlin whirly noise. And this is just my implementation of that Perlin whirly noise they're talking about. And when you enable this checkbox, these whirly details are overlaid on the cloud noise, and this gives a completely different characteristic to it, and you can use it to your like. But again, this is actually different from the look I've been showing you on the references, so I will be not using that in the demos actually. That said, one more interesting parameter to clarify is element size versus stretch. So If you want to make those sausage details a bit more stretched in certain direction, you would apply a larger element size like 5 here. But we have now a stretch parameter on the cloud noise, which I show you here. So if I go down, stretch set to 5 as well. So this preserves the finer details while still stretching the details out very similarly, and this just gives a much more natural look to the stretch details effectively. So then how is this all applied to making a cloud? So this is where the new billowy noise comes in. So, well, first of all, let's just show you the test subject, which is a volume sphere. So on this test subject, I apply the existing cloud noise node, which we had already for many releases. So I had several issues with this node, and when we consider the look of it, what it generates, one of the main concern is the jigsaw puzzle look I'm getting with it. So you can see here these like tips here that goes around like an edge of like a jigsaw puzzle effectively. So this is very unnaturalistic. So I could never really use this cloud noise to generate any realistic looking cloud noise really. Then the second thing is the little broken off pieces, which are really annoying, and when I model clouds, I kind of want to control them, either to have them or not. But currently with this cloud noise, you cannot control it. If you increase the amplitude and you like the amount, the amount of the displacement, but you might end up with these broken up pieces, and there is no way to control it. So to combat all of this, now we have the new cloud billowy noise, which meant to create all of these nice billowy details using the cloud noise I showed you before. So let's look at this one. So this cloud billowy noise is pretty much the default, nothing changed. I increased amplitude, added a bit of gain, and changed the octave. So nothing very harmful. But what you see here, it's, well, not really what I would expect. And the reason is because the iterations. So I kind of realized that the best way to apply billowy noise and to generate billowy noise is to take, again, what we see in the reference, which are all of these like, fractals, like larger and smaller and even smaller details. So therefore, I also added an iteration parameter on the cloud billowy noise. And as soon as I enable iterations, so in this node, nothing has changed. If I just go to the default tab, nothing has really changed, but just the iteration enabled to 3, and I immediately getting details that are a lot more interesting and looking a lot more like I would expect a billowy noise to look like. So all the difference is that I enabled iteration here. And then we have separate controls for advection, so this can stretch the details out, giving you even more interesting looks. And the best part of it is the attenuation. So here you can control how much in each iteration your amplitude, element size, or all other parameters are reduced. And here I'm saying that in each iteration, the value should be reduced to only 35% of its previous iteration. You can also scale them up as well. So you can go into the positive scale direction. So, and it's very interesting to play around with this parameter and see what do you get if you apply gamma, gain, bias, etc. So yeah, we came from something like this to looking, well, something like more of a cloud look. Then next thing is cloud clip. So I was mentioning we need a tool for clipping the bottom. So this is now called the cloud clip sub. So this is very much similar to what the clip sub does for geometries. It just does it for volumes, and you can also apply displacement to it. So when this is again based on the cloud noise, so all of the cloud noise parameters are promoted here, and you can able to apply some really interesting variation and patterns to the bottom of the cloud just like this. Then what is interesting is the workflow related part of this node. So here we split out both the bottom and the top, so later you can combine them in your workflow. And we have a thing called a clip mask. So if I display the clip mask, you will see that this is just a simple density volume that is 0 at where the clipping plane is, and the further is from the clipping plane, we can control the fading range, and we can get effectively a shrank mask out of it. So I could use this mask then to control, let's say, the wispy noise in the bottom of the cloud from the clipping plane. So this is super handy. And because it's a mask, we have to make sure that this mask encompasses all the regions where my noise might be displaced to. So therefore, we have upper and lower padding controls to then able to create a large enough mask volume out of this clip mask. And I will show you this in practice as well. The next thing is the wispy noise. So again, taking the blob shape I just created, I have to activate the VDB here. So making sure you have enough activated VDB cells, and then applying a cloud wispy noise, I'm able to create the wispy details. So again, work similarly. You have sort of sub steps telling you how many sub steps you should take, while also you have iterations home. You can apply the same pattern multiple times as well. But this node actually based on the already existing noise types like anti-alias, flow, etc. And what is more interesting in this node as well is creating wind. So if I show you this one, yeah, right here, for example, what you also notice in the Disney Cloud is that these wispy details, the further they are from the cloud shape, the more they start to bend towards the wind, which is a really nice effect. And if you, and I just have to change the visualization here. So if I convert the cloud to a VDB surface, and then provide that as a surface volume, then I can add wind, and I can scale the wind strength by this surface distance. So if I now disable wind, you will see that now the detail starting to stretch towards the wind direction. So after this, I think we're ready to show you an example of generating a cloud from start. So for this one, I use the cloud shape generate node. So this is very much like a Pyro burst source node where you can generate some random cloud shapes. So I just have here on the side another one of these nodes, and to show you an example, and I can change the seed, and I'm getting, a variety of cloud shapes. And this is made up of actually primitive spheres, and these primitive spheres are actually provided with a p-scale point attribute. So that means that you can just simply connect a VDB from particles nodes right after it for a very fast volume conversion. And again, going back to the node, it has a lot of options to control the shape. And again, similar to the Pyro burst source, you can just input a grid and you can just populate your sky with all different kind of shapes if you would like to take this approach for your cloud modeling as well. But right now I just go back to cloud shape generate, and using the setup, I just do a mountain to kind of vary the shape yet again. Then, as I said, I can just apply VDB from particles, and I do a cloud clip for the bottom. Then cloud adjust density profile is yet another new node. So here I want to create the same profile, density profile as the Disney Cloud does, and this is just because why not? So if I show you the Disney Cloud profile, this is how it looks like, which is one. Well, there is a value, much stronger value, like value of larger than 0.5 to 1 in these areas, and then the inside is like 0.5. And then of course with the wispy details, they also vary the bottom of it here. But then I'm able to create similar patterns here. So if I go back here, before the cloud billowy noise, I apply this density profile, and here I'm simply saying that the edge thickness should be 0.5, so this distance here, where the edge density should be 1, and the internal density, everything inside, should be 0.5. So after this, I run my cloud billowy noise, which generates all of these nice curly sausage details. So here, again, just some custom values, enabling gain, gamma. I apply advection to it that actually stretches out these details into even more kind of sausage patterny look, so which is really great. And then, yeah, just some actually very minimal attenuation settings. So there is really nothing much to it. Then next thing is another cloud billowy noise. And here I do not apply any iteration actually, because the first cloud billowy noise already did the job of getting the generic shape done. This is just to add a tiny bit more detail into the cloud, and that's some variation. But now if I show you the volume slice, now you will see that we're getting there. We are getting a very distorted shape around the edges with varying density values, while we have the inside set to 0.5, but this is very chaotic in the inside yet. So after applying another cloud density profile, I can just clean up the internal areas and then just make sure they're all, unified. Then let's clip again the bottom of it so that we have a flat bottom, but in this now I apply a displacement noise as well to create some interesting details there. And then now to apply the wispy details, I just do another clipping to just separate out a tiny random layer from the bottom with some random thickness. And then activate it, apply some fog, so that this will just simply multiply the density, so give it more variation. And then on the other side here, as I showed you before, I just convert it to a surface field. And now when I apply the cloud wispy noise, I will get something like this out of this. And then when I combine the two together, then I will be ending up with a very simple billowy cloud that has wispy details at the bottom. However, this is not the only way you can create clouds, and I want to show you another setup. So with this one, I use a line and scatter shapes around the line, then replicate those shapes, and then with the billowy noise and when it's volume, I can get some really nice details that matching exactly my input shape. So, and this setup was actually used to generate these clouds. So these are all like the same typical billowy clouds with wispy noise at the bottom, and I just line them up and then just having the camera pan through them. And we have another visualizer for Houdini for volumes, which is now we provide control over the ambient colors that you want to set. And when you set them to the right colors, you can get some pretty nice looking results like this out of the box. So the billowy noise SOAP actually has a checkbox with a visualizer that is able to just immediately turn on this kind of visualization. So it switches between this and the previously shown like gray look. So going back to the setup then, so this new setup, as I said, this will generate clouds such as this one. So this is the line which I was showing you, and the cloud shape from line does the shapes as I mentioned. But here for the setup, I did a couple of different variations actually. So there is one horizontal, and there is one where vertical, but I sort of bended it and I can get shapes like this one. And then in the setup demo, I just simply randomly did a random selection for each wedge to pick whichever source they want or the setup wants. So then the next thing is a flatten sub, which the purpose of this is that I can move these spheres or points above the ground so that the spheres sit actually on the ground plane. Now, this is a very much generic node, so I can demonstrate it on a plane. It's just a typical, it's not as like the clip node, which the clip would actually remove these primitives, but the flatten, it just simply moves the points to the clipping plane. And the nice option is you can enable a second clipping plane to clip something in between, and you can then move them all together. But if you want to do this, there is an actually simpler way to go single plane, and then you only have one single plane to control actually. And the nice thing about this is that it has a thickness attribute, and then this attribute is then considered into calculating the distance to the clipping plane. And this is actually the feature I can use here for the flattening of these clouds primitive spheres, because knowing the radius, now I can make them sit on top of the grid. So after that, I use the cloud shape replicate, which is a very custom like scatter replicate kind of mix. It's very artistic node. Whatever I find working is promoted here. So the purpose of this node is just to get additional details out from a shape like this. And then I just blast out a couple of more primitive spheres, and then I apply even more cloud shapes on that. And when I merge these two together, I get a shape like this, which you already seen on the image. And just another flattening so that everything sits on the ground, and the VDB from particles so to get the volume, and I'm getting this really nice shape here. Then what is interesting to mention on the right side here, I use a cloud shape from intersection. So this node finds out where are the intersection between the primitive spheres, and then it just replicates or copies more primitive spheres on those intersections. And here I copy just enough to make them look like it's a donut. And then merging the two together, it looks like this. And now you can see that it can be used to fill up the large like gaps between these primitive spheres, if that's what you need artistically. And just run another flatten VDB from particles, and I just simply run some reshape operation on it. And while this is not necessary, I just merge the shape back, this shape into the shape on the left, and I run the cloud adjust density profile again. And you will see that from here on, it's pretty much exactly the same thing. Except the only thing is on the right side, I take this shape which I created, and I just create a volume mask out of it, which drives the billowy noise. So because this is not considered as a mask, you can see that some areas were not as affected by, for example, here inside, by the billowy amplitude. And you can see it more at the bottom here. And now I can also use another billowy noise here, and this only applies to the areas which I did not touch much with the other billowy noise, so I can get some additional details there. So therefore, this is kind of trying to show you the kind of amount of controls you can have on certain areas of the cloud, similarly how the Disney cloud did it. And then as a next node, I just go on and do another billowy noise here, where I just only randomly push out some certain areas to give some more detail to it. And then from here on, it's again exactly the same thing, so I don't even think it's necessary to go over. You can even recognize the same setup here to make it wispy at the bottom. So I just simply jump to the actual generated cloud here, and then I just transform it, flip it, and I end up with this cloud. Now, when it comes to rendering, there are two ways. There is the sort of simple way, but less realistic. And then there is the, well, also simple way, more realistic, but takes longer time to render. So if we look at the less time consuming approach, then what you can do is to use a volume ambient occlusion node. And this generates an occlusion volume out of your density. And you can use it as an emission volume in your cloud shader to make it, look to create the internal scattering for the cloud, instead of actually calculating it by bouncing rays inside the cloud. So if I just enable this and I show you, this is the kind of result you got. Now, if I lower this, so again, this is how it is by just using a default Karma physical light. And if I jump to the shader, you can see that in the scatter option, I have the scatter ramp, and the scatter is actually driven by this generated occlusion volume. So you can get some really nice looking like occlusion details here, but the issue is that you kind of work against your light sources for your directional lights. Let's say if I now, just as I had it before, starting to increase it, you will starting to get more details into the cloud, but in the expense of this occlusion volume not being so dominant anymore. And you kind of have to find ways to balance it out and kind of make it work. It's depending what you like, but the good thing about this method is that you don't use any volume ray limit, so the rendering is actually can be considered rather fast. And actually, it should be even much faster. I just simply had a really large patch traced sample size here. So this is actually really fast. And the not so fast approach, but the more physically correct, is the multi-scattering. So this is the same setup, but I'm not using the this occlusion volume. I just simply set the volume limit to 32 and just apply the default cloud shader, but I'm getting a lot more interesting and more realistic looking cloud. And I just let it to render in the background, and I want to show you the cloud shader and talk about shading clouds actually. So to set up a cloud shader which works both on CPU and XPU, you would have to use the Karma volume, which is a wrapper around the material X nodes to render volume. So this has all the absorption, scattering options, anisotropy, and all other like options you need to render with clouds. And if you just want to create a very basic volume shader, effectively this is the setup for that. So a density which then can be multiplied up, and then you multiply one with the black color for your absorption, and you multiply one the other branch with value of 1 for the scattering, and plug it into the Karma volume. And pretty much that's how this is the most basic volume shader you can get. Now, what are all of these parameters and how did they get there? So taking this setup, there are certain modifications you can do to make it suitable for cloud rendering, and this is this network that shows this modification, and this is some sort of like a very standard way to render clouds. And I will have an example up in the content library that only show you with the test scene this setup, and you can implement this setup in any other render engines you want to successfully render some sexy clouds. But effectively the trick here is that we have a thing called density fall off, which is what we do here, and I dive inside to show you. I'm importing the ray level. So the ray level means that the bounce level of the rays. So when the rays start to bounce inside the cloud, because you remember I set my volume limit to 32. If I just show you here, volume limit 32, it means that the rays are allowed to bounce inside the cloud 32 times. And then this ray level will tell you like where is this bouncing at now, like 1, 2, 3, 4, or how many bounces has the ray done already. And by simply taking that and applying some exponential function to it, I can scale down the density with each new ray bounce. So effectively what I'm saying here is that the more the ray bouncing into the cloud, scale down the perceived density. And that will also make the ray limit to sort of to stop much earlier, because wherever the density will be perceived as 0, then the ray bounce will not happen again. So effectively you can also speed up your rendering by providing larger density fall off. But there are caveats to that, and I will show you later. But this is a very good way to get very nice looking clouds. So this is one part of that. And the anisotropy controls are based on the same principle. So inside here I also taking the ray import, and the anisotropy fall up tells me how fast I should be falling from 0.877, so the default anisotropy value, towards 0. So an anisotropy fall off of like 0.3 would like get the anisotropy down to 0 in a matter of like 3-4 bounces. And so these are the main components to it. And what we did is this density fall off, it's actually we integrated into the karma volume, and it lives as extinction modifier. So this is exactly the same parameter as this density fall off. So you do not need to implement this. And our Pyro shader, we have implemented this anisotropy fall off as well, which I will show you. And then when it comes to then cloud rendering, I show you the new Material X Pyro shader. So this is very much similar to the previous Pyro shader that we had, but it's much more modular, and I will come back to it in a bit. I just want to show you now the cloud options. So as you see, we have anisotropy as well as we had before, but this roughness, to enable roughness, this is exactly what I showed you here, the anisotropy fall off setting. So when you enable roughness, you effectively control this anisotropy fall off. And then here, the density fall off is promoted as extinction fall off. And then we have a couple of other controls here. Albedo contribution is, for example, telling you, you can set it to brighten up your clouds. And the start level tells you after how many ray bounces this extinction fall off should actually take effect. And the default is 0, so it will immediately, start to kick in. And so these are all great, and I prepared some actual render test, actually, how this whole thing actually looks like. So this is just me playing it a bit like a slower speed. So this is just a very standard cloud. As you can see, there is nothing else set other than anisotropy to a very high value, and I just increased the volume limit to 32, and you will see that the cloud getting brighter and brighter. And you can set it up all the way to like 250, which is our clamp value, but of course you will get like very, very slow renders then. So that is not recommended. So now, as a next step, I will be changing the extinction fall off. So after you set your volume limit, set your anisotropy, the next thing you should be setting is the extinction fall off. And this is a very interesting control, because as you see, there is a peak point where the extinction fall off is actually getting very bright, and then after that it slowly just dies off into like dark and losing contrast. And the important thing is that you have to find that peak point where your cloud is the most brightest, and usually this is between value of 0.21, 0.3, etc., something along the line like this. So after that, if I now pick my extinction fall off, which I set 0.21, then I can enable the anisotropy roughness, and you can see that I immediately get some really nice, fluffy, like powdery, like candy looking cloud. Like it's, this, the mix of these controls can really nicely bring out, some really nice details in it. And just to show you, if you pick an extinction fall off that is like, not in that peak brightness, then as you would see, again, here I just simply, just changing the anisotropy roughness the same way, but you see that the cloud never gets as bright and it has much less contrast. Maybe that's something that you want, but generally I think this picking the right extinction value, it's actually important. And then in Houdini as well, we have, talking about still anisotropy, we have another control here to use secondary anisotropy. So this is something that you would see in any other render engines implemented, where you can have a mix attribute and another anisotropy value to set. But well, there are pros and cons. So this renders the cloud somewhat sharper, but also you can introduce a lot more noise into your render, as opposed to simply just use roughness, for example, which I've been showing you. So roughness, as you've seen, did not cause any much noise, but sometimes you could tell that maybe your cloud a tiny touch bit softer than it should be. But again, and just to show you the secondary mix, so here I have the anisotropy 0.877. I have secondary anisotropy to 0. So this is the same value as my roughness would fall to if you would use the roughness settings, and I just changed the secondary mix in between. And you can see that based on different like mix values, you would end up with a much noisier areas in these regions as well. So, but again, the controls are there. You can even mix it. You can enable roughness with secondary anisotropy. So it's really, really up to you how you have all the kind of controls to make some sexy renders. Then the next thing is the albedo controls, which I quickly mentioned before. It just simply lets you, like, you know, scale up your brightness of your cloud, which again you can find here. And then what did not mention, but we have Karma Physical Sky. So this is what's been used to render all of our examples so far. And what is very important here actually is the right amount of light. So the cloud, the light, you have to provide enough light for the cloud to make it like nice and fluffy and bright, for example. So if your light is very faint, don't expect your cloud to be looking, you know, very fantastic. And then just to show you the output of this procedurally generated cloud. So this is now, they are all rendered using the cloud shader, and here I just simply animated our physical sky from, you know, sun from the morning till the evening, and you can see how the sun direction is changes with all the different throughout the all different variations. And then just quickly want to return to the Pyro shader. So we have now the Karma Pyro shader, and here I just stopped the rendering so it doesn't always restart. So we have Karma Pyro shader, which is the shader I've been showing you. This is the new shader that is good for both CPU and XPU, and this is made of, this is a modular shader, much more modular than it was before. So if I dump in, while it still has some nodes outside here, you can clearly see the modularity made of multiple different nodes like scatter emission and fire emission and etc. And what I mean by modular is, for example, the Pyro shader, which the previous Pyro shader, which we did for 18.5, it's, for example, had options for a secondary fire. So that was when you wanted to enable additional fires for the trails, for the tip of the trails that would fly out from an explosion. And when you have this all in one volume with the big explosion body, then you kind of had to have a second a secondary control over the emission for those little trails, and this is very arbitrary, like why to have a secondary one. And in the new Pyro shader we did not include this option, because what you can do now is to put down a Karma Fire emission node. So you can use this node and you can read in your whatever volume you want to read in, and you can just simply connect it to your emission, and this will serve as an additional emission. And this is the same node that actually here inside this node that drives the emission inside. And we have also separate nodes like the volume mask. So whoever is familiar with how the scattering emission works and how we mask things, now you can actually do your own masking outside of the Pyro shader and just simply connect it, into the emission part here, and it's a lot more customizable shader now. And lastly, when it comes to shading, I want to mention that now we effectively want to differentiate between what is a shader and what is a material. So this is our volume shader, but if you put down a material library, and you have now the option, you don't have the option to put down shaders directly, but what you have is you have presets to put down. So for example, you can put down a Karma Cloud material here, and this will give you a Pyro shader, and with all the defaults that you would need for rendering the clouds. And this has volume limit already set to a certain value, so you don't even have to set up the volume limit on your render node. It will automatically give you the right volume limit, which is really superb. And then if you want to go and do the occlusion rendering, then we have the Karma Pyro baked material, which will generate just in a second. And you can see here, this is actually set up to be used for the occlusion. So it's as simple. And then just diving in, there are other ones like Karma Pyro Fire, Explosion, Uniform Volume, etc. So check them all out, see how the defaults work. And yeah, pretty much that's all I can say about the new features. And then I can show you some other interesting bits, like, as I said, there is not much simulation example I did for this release. There is this simulation, the only one I did, which it's like a Pyro simulation where the smoke kind of just blowing towards the camera. And then this is how it is with rendered, and I actually really like this, like really like stormy darkening cloud look. So this is how I kind of went on rendering this. And then I did some, like, this is also another render of it with this is actually a 4K render of one frame of this cloud. And here I actually freeze the frame, and I apply the cloud billowy noise on the simulated volume, and therefore I could get a lot more finer details. Like all of these finer details are coming from the cloud billowy noise on top of that. Then lastly, for hero cloud generation, I have to show you the cloud you see in the presentation background. So these are just different variation of this. And I did one from the other side as well, just a bit of different coloration to give, some varied look to it. And I also did a close-up of this, so you can see that even when you zoomed in quite a lot, you can still get like some really great amount of details. And this cloud kind of served as a test on how I can generate like a massive cloud. So going to and here I will not show the full setup really, just a bit of it, but the whole purpose of this is that what if I have a billowy cloud like this, and I want to make a cloud that is just, you know, taking this entire setup, and now I suddenly want to plug in a mesh that is like 5 or 10 times larger, and will I get the same amazing looking cloud? And kind of the answer was sort of not really. So the reason is because when you're starting to make larger and larger areas, relatively speaking, the clouds, as I showed you in the references, have structures. Clouds or any kind of billowy details have so much like larger, and going back to this fractal in nature, that larger details are smaller and smaller details, and this is kind of hard to preserve when you kind of trying to scale up these effects. And I tried a couple of ways on how to approach it, and actually the best way which I settled with was that I actually used, instead of using a line and primitive spheres on it, I just simply decided to model the cloud. So it's nothing more than it's maybe taking a bit of time to remeshing, but it is simply just a polygonal mesh which I just quickly modeled, such as this, and then I used a cloud displacement on it. So this is again nothing more than taking the original shape, applying the cloud noise on it. I actually do quite a bit of a trick here, because I apply the cloud noise. So the attribute noise now is able to use a simplex cloud noise, which is the new cloud noise. And what I did here, I actually measured the gradient of this noise. And then after some smoothing operation, I just have a custom attribute triangle where I push out the geometry along the normal using the noise, but I'm also pushing them to the side using the calculated gradient, effectively to making it a bit more interesting looking, and to give it a bit of detail along the side of the extrusion as well. And effectively, I just randomly generated some shapes based on some reference image, and I just started to populate certain elements wherever I knew I want to add a couple of additional billowy details, and then running again another displacement on it. And again, this is going back to the fractal nature of the cloud, so that that I got this one, and then using another cloud displacement, now I can get the even smaller sausage details into it. And I think the new cloud noise is actually very, very good to get all of these details. And yeah, I just simply then end up with this cloud shape, and then I had a setup where I could just simply carve out the cloud shape into different sections. So I did a 4x3x3 box. So all of these just carve out their own little sections, and then I could use the same billowy cloud noise using the same settings on these little individual pieces. And then the result is, I can show you here, is looking just of a little piece is looking like this. So you can get some really great looking details just by going through each pieces. Of course, you can optimize this maybe because you might not want to, you might want to run it on a hollow shape, like just on the outside surface, and maybe you just fill in the cloud later. Here I just did it very simply to take the entire volume as it is, but you can see you can really get some, you can really tune in some super nice details into it. And one thing I noticed when doing cloud rendering is that when you can sort of push the details out, you have to push out the details in the viewport a lot more to be visible in the rendered. So what I mean by that is that you might think that in the viewport it has too much detail here, but the rendering might not. But in the rendering, it doesn't show up as well. So the point being is that don't be shy to make your volume in the viewport over detailed and adding a lot more tiny details, because that helps a lot more in the cloud render to make your cloud details, and the cloud will look somewhat less detailed anyway, what you will see in the viewport. So that's the whole takeaway from that. And then effectively, I just ended up combining these all cloud pieces together. And this is like a very high resolution cloud. So even this piece alone has 52 million voxels at least. So yeah. And then lastly, I want to talk about the Skybox node. So this is this is now moving away from generating hero clouds and more like generating like continuous sky pieces with procedural noise to create clouds. And this is the type of clouds that, or cloudscapes that you can get, for example. And you have several controls here on setting the size, setting the amplitude. I actually make this a bit lower resolution for the example. You can make curved sky similarly as before, but a bit, a bit easier control. You can move the center of the sky dome. Of course, you can make it a lot more extend. So you have all the kind of cool controls about it. You can also erode the boundary. So this is if you want to make a sky piece that, let's say, when you don't want your flat boundaries all over. And there are a couple of other controls here. There is the Billowy settings, and what is really nice is the wispy settings. So with the wispy controls, you can enable that certain parts of your pattern turn into, the kind of sort of wispy detail as well. And just to show you some actual variations. Oh, but before that, I think it's worth to mention the coverage controls. So these are the main controls over. So with coverage, you can control how much cloud do you want. We have precipitation and sort of anvil controls, so that it just fills up the top of the cloud, and etc. etc. And yeah, so to show you sky coverage. So this is again, just a small sky pattern rendered with animated coverage attributes. So you can see here how the clouds kind of just builds up, or the sky kind of just builds up from the clouds. And you can get some really nice, tiny details all across. And this video just shows different variations. So starting with the more billowy look, you can create all kind of cloud patterns with this node. And then going back, there is one other thing important to mention, are the sky fields. So the sky fields are 2D volume similar to the height fields. So in this example, I created a height field, I created a mountain on it, and I just use a sky field to add to this height field system. You don't have to, you can just start off straight away with this, but because I added it, I also moved up the sky field up to above the mountains, and you have certain, you know, different layers to automatically generate. And there are two ways to use sky fields. One is on their own. So what you can do is you can use a sky field pattern node that is, and now I disable the height field for better visibility. With the sky field pattern, you can create all kind of default pattern. The default is like the cumulus, the billowy details, but we have like some pre-made fractus, flocus, and other different pattern types that you can kind of use. And you can use this to just even just to render it. For example, you can put it to Karma and just render it when you don't want to generate a full 3D cloud, because these are like up high in the sky, and where like, you know, a simple 2D volume works, it's perfect for that. And because of that, you can also use a sky field from map node, where you can just you know, apply a monkey or any other you know, sky image you had, and then you can create your own sky field pattern ready to render. But the other option is to drive the Skybox using the sky field. So here I just simply apply the billowy noise, and then now, because the default sky controls the coverage, I can just set it to use sky layer, and then you will see that this will now adjust according to my generated noise. So I can even, you know, scale them up. Now the thing with this one is, the tricky part is that because you are sampling into a 2D volume, you will not get much vertical information out, so you will end up with this rather, well, ugly looking sides. And what you can do here is that we have control over the vertical like profile using the sample with noise. So here you will actually apply a noise to your sampling positions. Effectively, you are able to control the size much better. But as you see, the problem is, the caveat with this is that you have to be careful, otherwise you can destroy the actual underlying pattern that you created. So this is already, with this value, you already kind of getting a much nicer shape on the sides, while still relatively maintaining the pattern that you have created. And just to show you a couple of other, well, this is a render actually. So this is like from above a skyscape. So you can actually you know, generate like really good looking, you know, skyscapes if you need something very quickly. And then another less quicker method is if you want to compose a sky using multiple sky fields. And this is what I did here. This is like around 10-15 different skyboxes just simply combined together and rendered to give a much more customized cloudscape. And pretty much that's it for my presentation. So I hope you will enjoy all of the features, and I really hope that that you will have, you know, lots of fun with it. And I'm very much looking forward to see all the clouds you guys gonna generate.